All right, so we have this rectangle inside of a rectangle, and we're supposed to find the area of the shaded region. Let's just pretend that I can color inside of the lines, and that blue stuff's all in the lines. We want to find the area just of the shaded region, which means we need to find the area of the whole thing and subtract out this middle section where it's not shaded. So we also need to find that area. So let's start by finding the area of the whole thing. Actually, make sure you try this on your own first, but let's start by finding the area of the whole thing. So to find the area of the whole thing, it's going to be not triangle, 4x minus 2 times x squared minus 3. And remember that we have to multiply everything by everything. So I'm going to start with my 4x, and I'm going to multiply 4x by x squared. That gives me 4x cubed. Again with the triangles, 4x cubed. And then 4x times negative 3, that gives me negative 12x. And then I'm going to move on to my negative 2. Negative 2 times x squared is negative 2x squared. And negative 2 times 3 is positive 6. And then I'm just going to get this into standard form. Remember standard form, we look at the degree of each term and put it in order. So we have 4x cubed minus 2x squared minus 12x plus 6. Which that would be if we just had this rectangle and we were just finding the area of the whole rectangle, that's what we would get. Okay, then we need to find the inside rectangle's area. And that is x plus 2 times x, which is a little bit easier to do, right? We just have the monomial right here, and we just need to multiply that by everything in here. So that's going to give us x squared plus 2x. And then we're going to subtract this area out from our green total area, and that should give us the shaded region. So minus x squared plus 2x. Okay, 4x cubed, we don't have another x cubed, so we're going to keep 4x cubed. Negative 2x squared minus x squared, that's going to be minus 3x squared. Negative 12x minus 2x, that's negative 14x. And plus 6. And that is the answer. That is the area in terms of x of the inside rectangle. Now, this is kind of a side note, but this could actually be a thing. If you had a company and you made swimming pools and you had to have a certain area around that's concrete, something like that, but you make pools in different sizes. They're all the same shape, but different sizes. This x, you could say, okay, so I need this length. I need this length right here to be 12 feet. Okay, so if you need that to be 12 feet, once you know that dimension, you can figure out all the other dimensions. You can figure out the total area of the sidewalk area around it. You can find the total area of the swimming pool, and that would apply to all the different sizes for that length.
I mean, is a 16 in one class.
What?
I mean, is a 16 in one class after being very lenient.
Yeah, I finished my second period, and I'm like, everyone got an A pretty much, so good job, guys. And then my sixth period, half of them did really well. The other half hasn't finished. So. And then there's, of course, the super genius who's talking about parametric equations.
Hey. Yeah, I recommend you in calculus.
Yeah. I was actually going to have her, I'm not going to be this mean, but I was thinking about having her like, okay, so one of our students just did exceptionally on this. And so I'm going to have her come up and explain how she got this answer for this problem, because it's just amazing. Like it's above my level. And I just need her to explain it to the whole class.
Do it.
Do
do
A
it.
little bit tempted. I think that's too mean.
No, it's not too mean.
Oh, I have class right now.
Or when you do,